I'm Nikita Stupin. I have a Russian name. I have a Russian accent. I work for a big Russian company, but I do bug bounties internationally. And today we're going to talk about vulnerabilities of mobile OAuth. I'm working as information security analyst at Mail Group, and we're top 5 world mail service by daily audience. Also, I'm doing bug bounty as a part-time, and I'm teaching application security to students. And this research started when we wanted to implement secure mobile OAuth in our mobile apps. And as a first stage, I've just read RFCs, read all articles that were accessible for me, and then I've watched how companies like Google and Facebook implemented their mobile OAuth. And as a stage 2, I've got all paid programs from HackerOne and checked each program and saw whether it was vulnerable to whether there was vulnerabilities in their mobile OAuth implementations. So this research is based on real-world examples as well as accepted standards. Here is the plan. First, we're going to talk about OAuth at large and how it works, what's its purpose. Then we're going to jump right into the core of the talk and we'll discuss vulnerabilities of mobile OAuth. Then we're going to talk about vulnerabilities of classic OAuth because they still appear in the wild from time to time. So, OAuth protocol is a protocol by which third party can obtain access to user data, and usually it's done without asking user to enter their password and credentials. But later it was adapted for authentication and mobile platforms. And since authentication is kind of more complex process than authorization, and mobile is different from browsers, vulnerabilities arose. So, basically there are 3 steps in mobile OAuth. Step 1, obtain permission to access user data. And usually it's done by consent screen, and where user presses approve, or he presses chooses an account, and if he does so, now we have step 2, obtain authorization code. And usually it's done by 2 redirections. First redirection is from server to browser, ordinary HTTP redirection, and second one is magic redirection from the browser to the client app. And step 3, exchange authorization code for access token. And that's it. Now, using access token, mobile app can just go to the server and access user data. When we talk about vulnerabilities of mobile OAuth, we expect something really complicated, like this, for example. It's a shame, but in 2019, we have to take a step back and talk about using HTTPS. Last year, I found vulnerability in a really popular service. Should I tell you about it? Are you with me? Who here loves to travel? Raise a hand, please. Oh, not so much travelers. But you all probably know this company. And to demonstrate vulnerability, I'll show you a screencast. And I've got to admit that this screencast was made for Airbnb and not for public showing. And I'm not sure that you will be able to see this in detail, but let's try anyway. I will comment it alongside. And you will see Burp and me operating with 2 iPhones in the background. First iPhone is the victim. Second iPhone is the bad guy. So let's start. Now I'm just logging into Airbnb app using authentication through auth with Google. And we don't see much requests because victim's phone don't have birth certificate installed. We see only HTTP request, and this is the exact request we need. It's a request with the authorization code. And we just copy that code, and now I am, as an attacker, I'm just cleaning up SSL pass-through so we can see HTTPS requests from attacker. So as an attacker, I will start a auth process, but I will intercept request when authorization code is exchanged to access token. We're intercepting it and replacing attacker's code to the victim's code and just forwarding requests. And we see that there's 200 OK, and in this context it means we've successfully logged in as a victim. And as a little bit of extra credit, let's try to use this code one more time. So just to make sure that maybe it's not can be used several times. We see that with invalid code it returns internal server error, and now with the valid victim's code it again returns 200 OK. So it means attacker just can capture the code and log in as many times as he wants. So Airbnb addressed this vulnerability really quickly. So this report didn't go public. I've asked a permission to show it to you today. And Airbnb asked to mention their bug bounty program a couple of times. So, Airbnb bug bounty. Airbnb bug bounty. Thank you, guys. Now let's move on to the consent screens. And there are good ones and the bad ones. And the good ones are those who asking the user to just choose an account or click on approve. And the bad ones are those who are asking user to enter their login, password, and second factor if they have so. And why they're different? And the difference lies in how mobile app opens consent screen. And the good ones opens it using browser custom tab. On Android it's called Chrome custom tab, and on iOS it's called SF view controller or Safari view controller. And basically it's just like your ordinary mobile browser. It's just opens faster because there is no application switch. It's just opens browser tab in context of your app. And the bad ones using WebViews. And WebViews are basically like embedded browsers into native app. And this means that any data that WebView have can be read and written by the native app which opened it. So like any cookies, cache, history, and executing JavaScript can be done by a native app which opened WebView. And there are two benefits from using like browser custom tab. And the first one is that whenever user is like not entering their passwords anywhere, they're cultivating good habits, and it's in a long run it will make them more more resistant to phishing. And the second good point is that it's much nicer for user just to have them click on one button instead of remembering password, remembering login, and enter the second factor they have, so it's really painful for them. And note for those who do bug bounties, if you will report it to the company, most likely you will get NA, because really there's no direct impact on when you're using WebView. But in the long run, is as builders, as pen testers, we surely have to mention this in our reports, in our advices to developers, just to use browser custom tabs. And now let's move on to one of my favorite and one of most complex attacks on mobile auth. And before that, let's have some necessary background on how can we deliver something from browser to client app. And there are two ways. One way is custom URI scheme, and the second one is app link. We're not going to talk about app links much because they're not commonly used for these purposes, and they are not supported in some older versions of OSs. So we will focus on most commonly used way, and its custom URI scheme. And what is custom URI scheme? And it's like your ordinary scheme, like https:// or ftp://. But instead of HTTPS or FTP, you can write like anything you want, like foobar:// and so on. And anytime browser or other app sees that link, it will open the app which claimed the scheme. For example, your app claimed the scheme foobar:// and whenever browser or native app sees that scheme, it will open your app. Sounds pretty simple, right? But what happens when two different applications claim the same custom URI scheme? It turns out that on Android, user will be asked for choose an application in which he wants to open this link. And on iOS, behavior is undefined. In official Apple documentation, it said undefined. So it's not really so undefined, and to show that, let me present to you screencast. And on the screencast, you will see two applications. First one is Mail.ru production app, and second one is Mail.ru beta app. So they of course have the same custom URI scheme. And now let's see how installation order will influence which of apps will be open. First, I'm installing the beta app, and second, I will install production app. And now we open the link, and we see that beta app is opened. You can see it by little yellow badge on the app icon. And now let's try reverse order. So we remove both apps and now install production app first and beta app second. And as you guessed, now production app installed or opened. Now production app opened. So whichever app is installed first will be opened. With that in mind, let's move on to the attack itself. And consider the scenario when on user device there are legitimate app installed with malicious app alongside. And they of course claim the same custom URI scheme. And when we're returning authorization code from browser to client app, we cannot be 100% sure in both cases, in both iOS and Android, that authorization code will get to the right app, to the legitimate app. So basically, when malicious app gets the authorization code through inconsistency in custom URI scheme, it will just exchange this for access token and get access to user data. And how OAuth addresses this vulnerability? And it does so by big dirty hack called proof key for code exchange. And basically it's one more parameter, and client app adds this parameter to the first request, and this parameter is called code verifier. And then server gets this code verifier, saves it for later usage, and returns authorization code as usual. Later, mobile app just again adds code verifier in request to exchange code for access token, and server on his side gets saved value, gets value from request, compares them. If they match, it returns access token. If they do not match, it returns an error. And now let's try to understand why does this prevent an attack. And let's consider the situation when malicious app actually captures the authorization code. and now it tries to exchange it through access token. And it goes to the server, but one does not simply get access token without code verifier. And we're safe now, yeah? Not quite yet. By leaking HTTP log information into OS, RFC says, and actually I didn't met this in a real world, but if some of developers of RFCs added it to RFC, they have probably met it. So how to address this vulnerability when malicious app can just read the first request from the logs? And we do so by not sending the code verifier itself in the first request, but we're sending a hash from code verifier. And now server saves the hash, returns authorization code to the client, and client now wants to exchange authorization code for access token. He sends the code verifier itself, not the hash, to the server. And server hashes that code verifier and now compares the hashes. And of course, malicious app cannot get code verifier from hash because we're using secure hashes like SHA-256. And that's why it's prevented. And when you're testing for this kind of vulnerabilities, you should not be like, oh, there is code verifier, it's most likely to be secure, I'm just move on and test something like this, anything else. But no, you definitely should check how the defense is implemented. And in this case, you should check, you should play with code verifier and try to remove it completely, try to get code verifier from other user, and so on. And surely check that code verifier is random, long enough, and used only once. And now let's have some rest and talk about tokens and token management. And where do we store our access tokens and refresh tokens? And the safe place in iOS is keychain. In Android, it's internal storage or securely configured content provider. If it's stored in any other place, there might be vulnerability. There is not necessarily vulnerability because there are a huge array of possibilities by which developers invented how to store these tokens not in these places, and I cannot cover all of them, but the rule of thumb is if it's stored in keychain or tail storage, it's okay. If it's stored somewhere else, it needs deeper investigation. And other type of tokens is client secret. And as you know from classic OAuth, client secret is like password for the server. So whenever it's exposed, some of functionality is compromised. And you can check whether for different reasons, developers hard codes client secret to their mobile apps. And you can check whether a client secret is hard-coded by reversing the app, but I suggest you a little bit easier approach. Just open the burp, see the last request when authorization code is exchanged for access token, and in 99% of the time, if client secret is hard-coded into the app, it will be in this request. So you can do both ways, can reverse engineer, and you can just see the request and see the client secret. But again, note for those who are doing bug bounties, it's not always a big impact from client secret to leak, because it highly depends on how much trust server puts on client secrets. Some servers using client secrets just to differentiate one app from another, while others can give one client secrets like software rate limits or given access to additional functionality and so on. So it needs deeper investigation in each case. Now let's move on to one of my favorite and most impactful attacks on mobile and classic OAuth as well. And this is OAuth CSRF. And basically it's relatively easy to check. And what you need to do is Like you're as an attacker starting auth flow with your account, but you're intercepting that flow when you're about to exchange authorization code to access token. So you're getting this request, feed it to victim. After that, victim goes to the link and now gets to the attacker's account. And now it does some things in this account using the app, and now attacker later can log in with his credentials and get into the victim's account. But this is not really impressive because victim gets into account which is empty, and if it uses application previously, it might just log in and log out and log in with his ordinary account. But nowadays, often developers and companies using to link existing user account with a Google account, Facebook account to make users easier to log in. And it's totally game changer because now when you're using the same attack, you are linking the existing user account with the attacker's account, with the attacker's Google account, and now it's basically account takeover. And in this January, I've really found this vulnerability in some private program, but so I can't tell you about it publicly. But they still exist, and you should definitely check for them. And again, defense is kind of similar to code verifier, and this time we add a parameter called state. And basically it works this way. Client app generates state, adds it to the first request, and sends it to the server. Server does nothing with state, just copy and paste it to the response and send it to the client. Client gets state that he generated and saved, state from the response, compares them. If they match, it safely continues the flow. If they do not match, it interrupts the flow, and we're safe now from OAuth CSRF. And again, test defense, play with state, and check that it's long enough, random, and used only once. And for the next vulnerability, I have a small task for you, and it's to try to find vulnerability in 6 lines of code. It's a real production code from real web app, and basically there are 3 lines of code, because other 3 are just syntaxes. I know you can do it. Any ideas? Take your attention to post message and how it's used.
It's not verifying the origin of the...
Yeah. That's true. And the vulnerability lies in that they're using a star in a post message, and basically that means that whatever page opens this one will receive the post message. And in this case, in post message was authorization code. So attack worked like this. Victim goes to attacker.com. Attacker.com opens a consent screen in a separate tab. Then victims click on approve, because in that consent screen, nothing suspicious. There's just a legitimate consent screen was opened. And after that, authorization code is sent back to the attacker.com. And of course, we exchange authorization code for access token and get access to user data. But having victim to click approve in such unorthodox conditions is quite strong precondition, right? And I've investigated this resource a little bit deeper, and I found out that they did not have X-frame options on consent screen. And this again was totally game changer. Now attack was victim goes to attacker.com, clicks anywhere, and this click was translated through iframe to the approve button. And again, attacker.com just gets authorization code and gets access to user data. So it was a really fun case because iframe options often closed as NA was accepted, and actually I was paid for that bug. And you can get more details following the link below. It's publicly disclosed. And now let's move on to like regex bugs. Some classic regex bugs, and this is not my report, but I've decided to include it in my talk because it shows that even in 2018 there were bugs in companies like Twitter in regex, which led to account takeover. And basically there is parameter like redirect to URI by which in which you choose URL where authorization code will go. And if you mess up with regex checks on the server side, malicious attacker can like put his URL to his domain, and all authorization codes will go to his domain. And Twitter had this vulnerability. So whenever you check mobile auth, do not forget about like classic auth vulnerabilities. And let me summarize it for you. Whenever you building or testing mobile auth implementation, you should firstly take a big picture of this implementation, like how it's implemented, whether there are unorthodox transports, or maybe there are some additional steps in OAuth, because we can make mistakes even when we're just implementing standards and when we're adding something by ourselves to these implementations. There are much higher chance for vulnerabilities. And then do like simple checks, like that all requests are using HTTPS, that tokens are stored in safe places, and how consent screener is used. And then, of course, check for specific mobile auth vulnerabilities, and these are authorization code interception attack, and check for CSRF. And of course, do not forget about ordinary auth vulnerabilities and like regex bugs, and there are more of them, but I didn't include them. You can easily Google them. There is much more resources than on mobile auth. And that's it. Thank you for your attention. If you have any questions, you can ask them right now, or email me later, or write me on Telegram. Thank you.
Thank you, Nikita. Is there any questions?
Hello, thank you first of all for the presentation. During recommendation, you have speak about browser custom tab, and you have recommended to use it. So I didn't understand why this will solve the problem of replaying the token. And the second question is why we don't make some...
Can we have one by one?
Okay.
So one question. If your question was like, you didn't quite understand why we should use browser custom tabs, or...
Exactly, yeah. How this will solve the problem of replaying the token, authentication token.
What problem?
How browser custom tab will solve the issue of attack by replaying the authentication token.
Can you please provide an example of such attack and how it works?
For example, the attack that you show, the
authorization code interception attack.
Yeah.
Using browser custom tab does not prevent it. So it's like browser custom tab is better because it's nice. WebView cannot get cookies from the ordinary browser, so it will always ask users for enter their password login. So for user experience, it is much better when they're like clicking one button. It's much easier for them. Then just remember password, remember login, and then type them in.
So it is just for user experience, not for security issues.
Second, it's really good when users do not enter their passwords anywhere. Like whoever prompts their password, they're entering this. It makes them more vulnerable to phishing. And it's exactly what's happening when they're like logging into third-party app, and they're asking them, third-party app asking to enter their Google like login and password. So for user, it's like kind of strange. They do not understand how it works.
The second question is why we don't implement a mechanism that check also for the device. For example, the device ID, and make combination between device ID, password, and other information to avoid that we replay the authentication token.
So we are getting device ID to like your hypothesis that we can use device ID to prevent authorization code interception attack, yeah?
Exactly.
And how do you want to use it?
Making a salt, for example, by the password of your user and his device ID, and why not the...
And how do you know...
I'm just asking if is this possible?
No. I think no, because by just getting device ID, you do not know which user you want to log in, because device ID is not bound to any account, like by default. So I think it's not really possible in this scenario. Maybe if you will invent some other scheme, it will be possible.
Thank you.
Someone else?
Any more questions?
Hi, you are mentioning a lot mobile OAuth, but are you considering or studied any other authentication method?
Considering, excuse me, I didn't hear it. Consider it what?
Another or an alternative to mobile OAuth. An alternative to mobile OAuth, I mean another protocol or something else, which is...
another protocol, not
yes.
mobile OAuth, but another protocol for authentication.
Exactly.
No, I guess OAuth is one of the simplest authentication protocols. So this is why we just decided to implement that. And there are not so much others, like we have OpenID, and I don't know any else for specific mobile which you can implement and so on.
Okay, thank you.
Any more questions?
Any other questions? No? Okay.
Okay. Thank you.
Okay, now it's lunch break until 13:20. And please give a round of applause for Nikita.
Wait a second. I'm disequipping